Let's write down first fundamental theorem of calculus. First fundamental theorem of calculus said that f of x dx is equal, limit is a to b, f of b minus f of a. Now, where f is antiderivative, this uppercase f is antiderivative, right? And b and a are limits within, they define the interval within which we are going to integrate the function. So because we are using f of b and f of a, that is clear that interval a and b is closed interval. Okay, and the variable x is a variable of the integration. Okay, however, a slightly different situation we have where variable x is used not only as a variable of integration, but is used as a upper limit of integration. Let's see. So f of x integral we have from a to x, okay? And f, to avoid using confusing of using x in two different ways, so we place as a t is for the temporarily for the process of the integration, and then we can switch when we evaluate. We will use value of x. I'll show you because they said better 1 times to see than 10 times to hear, right? So f of t dt. So what do we have? A is a constant, just like here in the first fundamental theorem of calculus. Now, here, f, we have x as the f function of x. So f of x. Okay, let me clear here so we can have the formula clear. Okay. And f of t, we have a function. F is a function of t, that's all. Okay, let's evaluate basic function, definite integral as a function. So we have f of x is equal integral 0 to x cosine t dt. So at the point of x is equal 0, pi over 6, pi over 4, and pi over 2. So integral from 0 to x cosine t dt is equal to the integral of cosine. We know it's a sine, right? Sine t from 0 to x, and it's going to be equal sine x minus sine 0. which is going to be equal sine x. Now let's apply this x. I here have prepared already, so not to waste your time because it's too many. Now, using f of x is equal sine x, we can obtain the results that shows on this picture. So let me explain. So we know that when x is equal 0, we have here 0, and we don't have any arc here because any shaded arc, because x is equal 0, so there is no area. It's this line, right? And why I'm taking vertical line, not horizontal line? Because my f of x is equal sine x. Sine x, it's represented by y, vertical line, right? Cosine x represented by horizontal line, t in this case. Next, x is equal pi over 6. So pi over 6, what it's going to be? To find out the value of pi over 6, we take 3.14 and divide by 6, and we're going to get 0.523. So it's going to be this piece. Okay, and the vertical line of this x, pi over 6, it's going to represent the arc of sine, that it's going to equal 1/2. That's why they shaded this. Next, x is equal pi over 4. I'm taking from here, yeah? The values. So 3.14 divided by 4, it's going to be equal 0.78. As you can see here was in this one 0.58, I think. Here is 0.785, right? It's increasing, right? So vertical line, value of y, that's represented by sine, it's gonna represent it by this arc and shaded area underneath. Next is pi over 4. No, that was, yeah, pi over 6, pi over 4. Oh, I missed here pi over 3 also. Okay, not a big deal. Yeah, I was wondering between pi over 4 and half a pi. Okay, too much distance. So next, pi over 3 divided, 3.14 divided by 3, I'm getting 1.04. As you can see, slowly it's accumulating, right? Yes. And at the end, we are getting half a pi. 3.14 divided by 2, we are getting 1.57, half a pi. And that's because half a pi is filling out the whole this area because it's 90 degrees, right? Filling out 90 degrees. So you can think of f of x as accumulating the area under the curve f of t. Under the curve f of t is equal cosine t. I'm sorry. Cosine t from 0 to x, right? Okay. And the area is changing from 0 all the way till half a pi, correct? And f of half a pi is equal 1, right? And that's what we have. The entire the quadrant is shaded at the end. So this type of interpretation of an integral we considered as an accumulation function, And it is used often in application of integration. Okay, note that the derivative of f is the original integrand, right? If you take derivative of f, right, which is sine x, if you take derivative, you go back to cosine, correct? Let me write down d of dx f of x equal d of dx sine x, right, is equal d of dx integral from 0 to x cosine t dt, right? It's going to be equal cosine x. So this result that is generalized is called second fundamental theorem of the calculus. So the second fundamental theorem of the calculus says that if f is continuous on an open interval that contain a, then for every x value in that interval, we can write down, let me take thicker, we can write down that d of dx, d by dx, integral. Just in case if anybody is wondering why cosine u we multiply by 3x squared, we can come back here and let me copy to this part. And I'll bring it here. Okay, so what do we have? df, okay, let me, so we have df by du, right, which is going to be our cosine u after we replaced it, right? Cosine t with u, we got cosine u, correct? And here we have du by dx, and our u is du by dx is equal x d by dx of 3, no, x cubed. I already was writing down the derivative, x cubed, and that's going to be 3x squared. This is where from we got this 3x squared. And in the second line, where I'm rewriting cosine u replaced with x cubed and 3x squared, it's already there. Okay? So you can turn around and verify if you want to. It's quite easy. So let me write down f prime of x. This is going to be our answer. All right, so our f of x, right? Is equal cosine x cubed times 3x squared. Okay, so not always, obviously, but sometimes it's easy to verify. So if you plug back cosine t, let's see. This time I'll verify for you. X cubed cosine t, my hand is automatically going to x because it's a habit already. So equal sine t pi half and x cubed. So this is going to be equal sine x cubed minus sine half a pi. And this is going to be equal sine x cubed minus 1. So in this form, we can apply power rule to verify that the derivative f is the same as the one we got it via derivative, which I mean this one. Okay, let's do it. D by dx sine x cubed minus 1 is equal cosine x cubed times 3x squared. And we got derivative of f. All right? Okie dokie.